In the last video, you looked at solving one-step equations with multiplying and dividing, one-step equations with adding and subtracting. Hopefully the steps for solving were something you remembered from 6th grade, from earlier in 7th grade, and it wasn't too bad for you. We're going to look at some specific cases, some odd things that start to happen when you're dealing with these inequalities. So we've got a couple examples, and I'm going to go through these 2 examples, and then maybe do 3 examples on your own to check it and see if you're able to work with these oddities, these kind of odd situations that pop up. So this first one, we're going to solve it normal way that we've been doing for a little while here. Negative 50 is greater than or equal to 5 times q. So I divide both sides by 5. I get that negative 10 is greater than or equal to q. Now, I'm just going to double check and make sure that works. So I'm going to pick a number that's less than negative 10, because negative 10 is greater than or equal to q. So if that's true, negative 11 is a potential solution for q. Negative 11 is greater than, or excuse me, is less than or equal to negative 10. So negative 11 is a solution. We've solved it. Negative 11 is definitely a possible solution for q. If I plug that back into the original problem, the original inequality, that means that negative 50 should be greater than or equal to 5 times negative 11. If negative 11 is a solution, this should work. 5 times negative 11, negative 55. Is negative 50 greater than negative 55? Yes. Yes, it is. So I've solved it correctly. It works great. I'm going to graph it. So if you're thinking, so what was the point of that? Just wait. And so we've got negative 10 was my solution. And if I'm going to graph it, negative 11, negative 12, we have our potential solutions right over there. And so that would be our graph solution for that inequality. Let's look at the next one. Same idea. Same idea. I'm going to solve for q. So I'm going to divide both sides by negative 5. Negative 50 divided by negative 5. 10 is greater than or equal to q. So then I find a potential solution. I'm going to double check again and make sure that it works. Find a potential solution. Let's say q is 0. 10 is definitely greater than or equal to 0. So q could definitely be 0. Let's plug that back into the original formula. Original inequality. Negative 50 is greater than or equal to negative 5 times 0. All right, let's see. Negative 5 times 0 is 0. And negative 50 is greater than or equal to 0. No. No, negative 50 is definitely not greater than 0. Negative 50 is assuredly less than 0. That can't be right. So I double check my work. Now it was negative 5 times q. So I divided by negative 5. That's the inverse operation. That's what I've been telling you to do the whole time. Negative 50 divided by negative 5. Yep. When I divide by a negative, I'm taking the opposite. So I get a positive 10. That's done correctly. Something is amiss here. This would be that odd situation that I was talking about. Let's see. What would make this true? Well, if I flipped it around, 0 is greater than negative 50. So that's true. And in fact, what ends up needing to happen is you need to pick a number that is the opposite here. I just said that in a really poor way. What we end up having to do is, since we divided by a negative, we have to take the opposite of the symbol that goes in between. If we do that, and we pick a number that is not actually less than 10, but a number that's greater than 10. Let's try this. If we pick a number that's greater than 10, say 11. 11 is greater than 10. If I plug that in, negative 5 times 11, that gives me a correct answer. When you multiply or divide by a negative number, you need to flip the sign around. Instead of less than, you have to make it greater than. Instead of greater than, you got to make it less than. And really, we've been doing this all along. It just didn't make a difference. When we had negative 50 equals negative 5q, and we divided by negative 5, if you flip the equal sign around, you just end up with the equal sign all over again. And so it didn't make a difference. We didn't notice it. But when we divide or multiply by a negative, we have to flip the symbol in between, because negatives are opposite. Negatives are opposite of the positive. So when we divide by a negative, we're really taking the opposite of everything. And with an equal sign, we didn't notice it because it's an equal sign. But with an inequality, all of a sudden it does make a difference. And so the solutions to this problem is that Q is greater than or equal to 10. You solve it the same way. We just have to remember that if we divide by a negative or multiply by a negative, we have to flip that symbol around. And that's those really kind of just strange things that end up happening when you deal with negatives and when you deal with inequalities. So Q is greater than or equal to 10. My arrow is going to go this way. And that would be our solution. So you solve the problem in the exact same way you did in the last video and in the homework assignment and on the post-test. Just remember now, if you're dividing or multiplying by a negative, flip the symbol around to give us a correct solution. Try these three on your own. I'm assuming you tried these three. I'm assuming you paused it, worked out the problem, double-checked your negatives, flipped symbols if you needed to. The correct solutions for this first one should be that x is less than -7, and there's the graph. Correct solution for the second one, 24 is greater than or equal to x, and there's the graph. And the last one, x is less than -3, and there's the graph. If you didn't get the graph correct, if you didn't get the solution correct, make sure you watch the linked video.